Okay, this is going to be a last video for 9.3. This is going to be how to find the measure of an angle. Okay, so again, we have to kind of use the combination of the identities and geometry to help us figure this out. So in the problem, I'm given that the tangent of theta is 5/3, okay, and theta is in the first quadrant, and we want to know what angle is theta divided by 2. So we want either radians or degrees for this one. Okay. Well, I'm going to start with what I know. I'm going to draw my little triangle. If this is theta, the tangent is opposite over adjacent. So this is going to be 5. This is going to be 3. Okay. And then I'm going to need Pythagorean theorem to help me with this. So 5 squared plus 3 squared equals x squared. So that's going to be 34 equals x squared, which gives me that x is the square root of 34. And there's nothing I can break this into that has is a perfect square. So I just have to leave it like that. So x is the square root of 34. Okay. So tangent is opposite over adjacent. So the sine of theta is the opposite over hypotenuse. So that's going to be 5 over the square root of 34. And I know that this is not rationalized, but we're just going to leave it for now because we can always rationalize at the end. And the cosine of theta is going to be the adjacent over the hypotenuse. So that's going to be 3 over the square root of 24. Okay, so I kind of have lined out everything that I need. And I want to know what angle theta divided by 2 is. Like, what's the actual measure of that angle? So because I started in tangent, I'm just going to go ahead and use my tangent identity. So I'm going to use the tangent of theta over 2 equals 1 minus the cosine of theta divided by the sine of theta. Now you can get here with any of the 3 versions of the half angle identity for tangent. I chose this one because it doesn't have a square root, and I just preferred not to work with a square root. So I'm going to put my values in. So this is going to be 1 minus 3 over the square root of 34 divided by 5 over the square root of 34. Okay, so we just have to not be afraid of these complex fractions. So if I can make the numerator into one fraction, then I'm just dividing by a second fraction, which means I can multiply by the reciprocal, copy dot flip. So I've got to make this into one fraction. So I'm going to do that by changing 1 into the square root of 34 over the square root of 34. So minus 3 over the square root of 34, all divided by 5 over the square root of 34. So let's not forget that we're finding the tangent of theta over 2. And what we really want is the actual angle of theta over 2, but we'll get there. Okay, so I'm going to take this. So I'm still finding the tangent of theta over 2. So that's going to be the square root of 34 minus 3. Oops. Divided by the square root of 34. So that's this fraction. Divided by 5 over the square root of 34. So now that that's one fraction, I can copy dot flip. So that's going to be the square root of 34 minus 3 over the square root of 34 times the square root of 34 over 5. And I was hoping that this would happen. So that's going to give me the square root of 34 minus 3 over 5. That's, again, the tangent of theta over 2. Okay, so at this point, I really can't do anything else other than put this into my calculator. So when I put it into my calculator, I get that the tangent of theta over 2 is approximately equal to 0.57. Okay, so that's the tangent of theta over 2. So I'm going to have to use the inverse tangent to find the angle. Because remember, this means that the inverse tangent of 0.57 equals theta over 2. So if you put this in your calculator, inverse tangent, and then I was in degrees in my calculator. So when you put that in, you'll get that theta over 2 is 29 degrees. So theta over 2 is 29 degrees, which would make theta 29 degrees times 2, which is 58 degrees. So theta is 58 degrees, theta over 2 was 29 degrees, and they really only wanted the angle that was theta over 2, but we can tell them both. Okay, so your last section is going to be, again, 9.3, 53 to 63, the odds.